In this lesson, you are going to learn about decimal place value, representing decimals with base 10 blocks, and comparing two different decimals. Let's start with just decimal place value. Decimals often just look like a period. The first place to the right of the decimal is always the tenths place. Recognize that when we say tenths place, that place has a THS sound on the end of it. That's an easier way to get it so you don't get it confused with the tens place. The place always to the left of the decimal is the place you know really well, the ones place. The place after our tenths place, or if we keep going smaller to the right of the decimal, is the hundredths place. Let's talk about these three places right now, and let's talk about how we can represent those with base 10 blocks. Let's say we have a 2 in our ones place. That means we have two wholes. Sometimes our ones place is represented with a flat or a hundredths grid that kind of looks like this. Now to represent the 2, we would need two flats if we were using the base 10 blocks, or 200ths grids. Sometimes in textbooks and on worksheets you'll see them represented as just a square. Now let's take a look at our tenths place now. Our tenths place is actually smaller than 1. So let's assume we have a 3 in our tenths place. We know that these flats that we used to represent our 2 are each worth one whole. Now since our tenths place is worth something smaller than 1, we need to represent our 3/10ths with something that is smaller than our flats or our 1 that we have. So we can represent our tenths place with longs. 3 longs will represent the 3 in our tenths place. Now the reason that we use longs, and the reason that we can represent a tenths place with a long, is it takes 10 times for one of these longs to fill up one of the flats. For example, if I tried to fit these in here, it would take 10 of them to fill up a whole flat. Now we've represented the decimal number 2 and 3/10ths. Now if we wanted to add another digit, we could add a 2 into our hundredths place. Now this decimal number that we have reads 2 and, we read our decimal point as an and, 2 and 32 hundredths. Now to represent the 2 hundredths that we added into our decimal number, you'll often see this hundredths place represented with a cube. Now we'll need 2 of those cubes to represent the 2 in our hundredths place. Now just like with the 3/10ths that you saw here, we named those tenths because it takes 10 of these to fill in one of these. Well, we can name these smaller cubes for our hundredths place. We name those hundredths because it takes 100 of these to represent one of our wholes. It's also important to understand that as we move down in place value from our ones to our tenths to our hundredths, we're moving to smaller and smaller values and smaller places. You're moving farther and farther away from 1. Let's take a second to think about how we read these numbers. Reading a decimal is very, very simple. When we come to our 2, we'll read our 2 simply as 2. When we come to our decimal place, we read that decimal simply as and. 2 and. Now we focus just on the numbers after the decimal, or to the right of the decimal. We say that number as we see it, 32. But we'll say the name of the last digit. That last digit is in the hundredths place. So we'll say that as 2 and 32 hundredths. Always saying the name of the last place that you see. Let's try another one. Now we know that our ones place is to the left of the decimal, tenths place is to the right, hundredths place is your next place. Now let's add another place in and let's look at the thousandths place. If I was to read this number, I would just be saying 2. If I was to read this number, I would say 2 and, when I get to the decimal, 3/10, because I'm naming the tenths place. Let's add a digit. Let's add 4 this time, and let's add that into our hundredths place. Notice the THS on the end. Now we would say the name of the last digit, and we would hear the decimal being read as 2 and 34 hundredths, saying the name of the last place or the last digit. Now let's add a number in the thousandths place. Remember, going to the right, we're getting even smaller. This is our thousandths place. Now we would read this number as 2 and 345 thousandths. Let's try comparing this number with another number. Let's compare 2 and 345 thousandths with 2 and 521 thousandths. Now, just like when you're comparing whole numbers, you start with a digit that is worth the most value. In this case, we know that our 2's have the largest value because places to the left are always worth more than places to the right. So if we look at our 2 in our ones place, they each have the same digit, and this place can't tell us which number is greater or smaller. Let's look to the number to the right of that. Now, we're looking at the tenths place. Our 3 on the top is smaller than our 5 on the bottom. So we can see that our number on the bottom, 2 and 521 thousandths, is actually larger than the number on the top. Let's try this again with different numbers. Let's say we have the number 5 and 4/10, or the number 5 and 32 hundredths. When comparing the two different decimal numbers, remember you always start in your largest place that you see. Now we see number in the ones place in each of these decimals. That digit or that number is the same. So let's move to the next place. Now we see a 4 in our tenths place on the top number and a 3 in our tenths place in the bottom number. That 4 in our tenths place in our top number tells us that this number is larger. 5 and 4/10 is larger than or greater than 5 and 32 hundredths. Notice that the number on the bottom, 5 and 32 hundredths, is actually longer. When you're dealing with decimals, the length of the number isn't as important as the value of each place that you're looking at. Remember to always start on the digits, the place values, to the left because they're worth the most value when you're comparing two different decimal numbers. Also, when you're reading a decimal, make sure that you say the name of the smallest or last place that you see.